Okay, I don't see any file. Student, all of you downloaded the file. If downloaded and open is okay. If you couldn't download, let me know. I want to be sure that you have the Excel file. Okay, are you ready? If ready, just send yes to the chat box, and we are going to take off. You ready? You hear me, all of you, student? Yeah, yeah, okay. Um, so yeah, after working on this training, I supposed to you that learned about this four. What is the meaning of the model fitting? The basic definition. What is the linear and non-linear model fitting? Also about the linearization of non-linear models using also the least square method for model fitting. Um, uh, okay, for warm-up question, please go to the Menti and use this code to answer something maybe interesting for you. Okay. This one. Okay. Okay. Let's go to Menti and use this code. Okay. Okay, guys, come on, come on. A, B, X, Y, Z, X and Z, A, B, Y. Okay, come on, guys. Yeah, I want to know. Yeah, okay. Come on, come on. In function y equal to ax plus bz, which term is or which terms are uh, variable? Okay, x and z, y, a, b, z. I want to know your opinion. Okay, okay, hey guys. Okay, x and z, a, b, y, a, b. Okay. Oh, just y. Okay, come on, come on. Okay, okay, thank you. Yeah, most of you almost correct, but for uh, clearing this one, yeah, yeah, yeah. Okay, okay, great, great, guys. Okay, thank you for the file. I can download from the link. Okay, I don't know. I will when we are starting the working with Excel. If somebody have problem, I will again send the file to them. Now, if somebody can upload somewhere else the file and share the link, please help the student to download, because some of the students got problem to download the uh, file. Okay, so yeah, most of you doing correct. X, Y, and Z are variable here. Yeah, yeah, correct. And I want to stop this one. Okay. Yeah, most of you correct. First, we define the variables. Variables and function. A variable is a, I don't know why the students coming late. Uh, a variable is a quantity that can assume any value. Yeah, it means that can assume any value. Um in the algebra expression, variable are present by letter from the end of alphabet. We use for variable x, y, z, t from the end of the alphabet. We use this one as variable. In an algebraic expression, the letter from the beginning of the alphabet often represent constant. Now from the beginning, A, B, C, K, M, mostly A, B, C, and also K and M, using as the constant. That is, their value are fixed. When we are using in a expression, they are mostly fixed value and cannot change. For this reason, we call this one as uh, constant. Constant. So in functions, we have variable and constant. Thus, in the expression ax equal to 2by, x and y represent variables and a and b are constant. A function. What's the definition of function? Function represents the mathematical relationship between variables. Yeah, between two variables. This is a function between two variables. Thus, the temperature in a solid that is being heated in an oven, uh, maybe here, solid that is being heated in an oven may be expressed as a function of time and position. Now, when uh, solid material is started to heating in an oven, increasing the temperature is a function of time and position. Different position, different temperature, and during the time, the temperature will be changed. So we write this one: T temperature equal a function of x and t. A small t represent the time, and x represent the position. So this is a, we call this one as a function. In a function, in an algebraic expression, y equal 2x plus 4. This is a function. Y equal to f function of x. Y equal to function of x. And so fx equal to 2x plus 4. We could rewrite like this one, function of x, or also we can write as a y. Now, if x equal to y, we sometimes write y is equal to x plus 4, sometimes writing fx, function of x is equal to 2x plus 4. Variables may be dependent or independent. So x, y, z, t, sometimes we using this one as dependent and independent. Um, unless defined, means that if we define, it is sometimes different, but uh, generally dependent variable in a mathematical expression is that one stand alone on one side of an equation. No, y, this is the, we call this one as y is dependent, stand alone. Y is equal to fx. Here you can see you change the position, you change the time, and measure the temperature. So the temperature is dependent, x and t are independent in this uh, expression, in this function. In the expression y equal to fx, y is dependent and x is the independent variable. In physical or chemical systems, the interdependence of the variable is determined by the design of experiment. When we design the experiment, we must show that which variable we want to change and which variable we want to measure. The variable we are measuring is dependent, the variable we are changing is independent. The dependent variables are those fixed in the design of the experiment, are fixed. We fix, for example, we fix the concentration of some additive, and then we measure the acceptance, we measure everything we can measure over there. So the independent variables are those fixed, it fixed during the design of experiment, and the measure when every characterization that we measure are dependent variable. So the dependent variables are those that we measure. For example, when determining the loss of ascorbic acid in stored canned food, loss of ascorbic acid in stored canned food. ascorbic acid concentration is the, because we want to measure this one, it's dependent variable, because it's loss, it should be the independent variable is time. So when determining loss of ascorbic acid in stored canned food, the ascorbic acid concentration is dependent and time is an independent variable. On the other hand, if an experiment involves taking a sample of a food and measuring both moisture content and water activity, sometimes we measure both moisture content and water activity together. Either of these two variables may be designed as the dependent or independent. Sometimes we measure, we say that moisture content is a function of water activity. Sometimes we say water activity is a function of moisture content. So it's based on the designation, based on the experimental design. It's different meaning. Moisture content depend to water activity. Sometimes water activity depend on moisture content. In a statistical design, the term we call response variable and treatment variable. Treatment variable is independent variable and response variable or variables are dependent variable. Response in the statistic we call as response, this one as treatment. So if you read somewhere that there is response variable means dependent, treatment variable means independent variable. So another thing that you should know before doing the training about the graph. When you measure something, you have a set of number that the values are independent and dependent. For example, for one special uh, one special water activity, you measure the moisture content. So you have one set of the numbers representing the value of independent and dependent. Or sometimes as a one time you have one concentration, one time one concentration, and also in one position you have one temperature. So each data point obtained in an experiment is a set of numbers representing the values of the independent and dependent variable. Experimental data are often presented in table as numerical value. When you want to present the data, you need to report by numerical value in a table or as a graph. You can show in a graph. The best method is graph. Graph is easier for reading, and also it is easier for the understanding the tracement. The graph traces the path of the dependent variable as the value of the independent variable are changed. Now, when independent variable change, the graph showed or trace the path that dependent variable where is going. Dependent variable over the independent. When all variable in a function have the exponent of 1, when all have exponent of 1, the function is called first order or linear function. In a expression, if all the exponent of 1, the function is called first order or linear function and will be represented by a straight line. When you want to draw, it will be a straight line. When any of the variables has an exponent other than 1, the graph will be a curve in a rectangle or Cartesian coordinate. When it's not 1, when it was not as exponent 1, so after that it will be as a non-linear or is in the curve shape. The numerical values represented by a data point are called the coordinate. So we have coordinate that represent the data point. Data point is a pair of the dependent and independent variables. When plotting experimental data, the independent variable is plotted on the horizontal axis. No, don't forget this one. Independent variable coming to the horizontal axis, and the dependent variable is plotted on the vertical. No, dependent variable should come on vertical, independent variable should come on horizontal. If you change this one, it's okay, but it's like you wearing sometime you wearing your shoes, then after that you wear your socks over the shoes. It's not acceptable. Mostly it can be you can wear your socks over your shoes, but mostly we first wear the socks and then after that wear the shoes. So don't forget that horizontal axis must be independent variable and vertical axis must be is dependent variable. Okay, so again going to the Mentimeter and respond to this one. Going to the Mentimeter. Okay, here going to the next one. Okay, going to the next one and respond to this question. Which of the following functions could be linear? One, y equal to ax plus b, 2yx equal to 1, 3y equal to x power n could be between -2 to +2. Which of them can be linear? Um, Only one, two, 1 and 3. All three are linear. 2 and 3, 1 and 3. Okay, come on, guys. Okay, 37. Come on, guys. Come on, guys. Respond to this question. Only one is linear. Okay, are you sure? Are you sure that only one is linear? How about two? Cannot be 1 and 2. 1 and 3. 2 and 3, only one is linear. Okay, okay, come on. Okay, guys, going back and see. Okay, right here. You can see, yeah, the first one, the uh, is ax plus b, yeah, because the y and x both have exponent 1, so both are this one must be linear. Second one, no, the second one is y is equal to x power minus 1. It's not be in an expression, in a function. It's not wrote as a function. If you write this one as a function, y is equal to x power minus 1, so it's not uh, linear. But third one, if n, no, n between minus 1 minus 2 plus 2, if n equal to 1, if it equal to 1, um, y is equal to x, so it's linear. It could be, can be, no. If n is equal to 1, it could be linear. It's depend on n, what's the power, and n can be, because n is in the range. So sometime make sure that do not be confused about the linearity of the equation. Okay, Nihal, thank you for um, your response. Okay, the next step is equations and fitting. An equation is a statement of equality. Equations are useful for presenting experimental data because they can be mathematically manipulated. Furthermore, if the function is continuous, interpolation between experimentally derived values for a variable may be possible. You know, when we have a function, and in the, in the experiment, you are just can take some data, you cannot take all of the data. For example, loss of antioxidant during the time, you cannot measure for all the time, but you can measure for some time. Then by the fitting a model, by finding a model, you can easily predict at each exact second, each exact time. So the equations can help you, and fitting can help you to fit your experimental data to a mathematical expression. Furthermore, in the function, it's yeah, if it's continuous, sometimes some equation are not continuous, like this equation. This one is at x equal to 0, it's not continuous, so we cannot predict at 0. But the other part, in different x, we can predict. Experimental data may be fitted to an equation. No, the meaning of fitting is that the experimental data can be satisfy an equation by using any of the following techniques. We have different techniques, but most of them are linear and polynomial regression. I will show you how we can do this linear and polynomial regression through the Excel. Linearization, sometimes we can linear a non-linear equation, and I will show you. Then data transformation, we can transform our data, and linear regression. After that, we use the linear regression, and we can also using the graphing. We can graph the data, and by the graphing the data, we can find a relationship between the dependent and independent variable. The first one is linear equation. Plotting of linear equation, plotting of linear equations can be facilitated by writing the equation in the following form, like this one: y equal to ax plus b. We call a as the slope and b as the intercept or y-intercept. This point, the b, uh, this is the point that ordinate at x equal to 0. When we put x equal to 0, this one y is equal to b. Yeah, this point, we call this one as intercept. The b is an intercept and a is the slope. So by uh, using this equation, we can plotting a linear equation. So first one, I want to start from this example, example one. I am reading through. The protein efficiency ratio PER of a protein is defined as the weight gain of an animal fed a diet containing the test protein per unit weight of protein consumed. This is a definition. Data is collected by providing feed and water to an animal, determining the amount of the feed consumed, and weighing each animal at designated time intervals. So after a specific time, we measure the weight of the animal. The PER, protein efficiency ratio, may be calculated from the slope of the regression line for weight of the animal y, this is the weight of the animal, against cumulative weight of protein consumed x, y, and x. The data expressed as x and y. X is the amount of the protein fed and y is the weight of animal, where x is the amount of feed consumed and y is weight, and it's as follow: 0, this one, no, each of them have one coordinate, one data point. A different animal we have here, we feed 0 and the weight was be 11.5, like this one, all this. So by regression or by plotting, we want to measure the PER. PER is the slope um, of this line going through the uh, all of this data. Okay, so please open your Excel file. The first tab is example one. All of you have the I should check the, yeah, all of you have the file. If you have not, please put any comment on the um, here, and if you have, you are going to, all of you have the file, you download the file. Okay, starting one, yes is enough for me. Wejia, are you alive? Jingmin? Oh, okay, 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 thank you. So okay, thank you all. So starting, we have this x, this x value, and this is y value. y is the weight of the animal, and x is amount of protein that we fed to the animal. We want to do a um, regression and find the A. A is the PER, or protein efficiency ratio. So we want to uh, plot this data. For plotting the data, each coordinate, each data point, zero, it should become like this one, x and y. This is coming from the Word file. Yeah, I have translated here to this one. So first, if you click here and then going to take insert a graph, it is automatically bring and put it this one as x and this one as y. But please, I want to show you how we can bring by the hand. Please click in one point is far from the data, not near the data. If you put near the data and press the insert graph, it instantly make this one as x and this one as y, and it's automatically drawing. I don't want to do this one because in the next experiment maybe we have another x y, and we don't want to do that. So please click on a far from on a play on a cell far from. First thing that just as a short thing about the Excel is you know uh, is a is a useful tool that include lots of cells. Each of the cell have one coordinate, that the coordinate is have one column name G and one row name G. This cell have a reference number as G9. It's wrote here. You can see from here. Or maybe this one is F13. This cell is F13. Just this one. Later on, I will discuss more. So first, click the far from your data. Then going to the insert menu. Here, insert charts, and in the charts, um, for model fitting, all time using the scatter, and insert the scatter. Insert the scatter and choose the scatter one. No need to line for now. Okay, this one I put the scatter, and we have one empty sheet here. This empty sheet, we want to put this data as x on the horizontal because this is a independent variable, and this is the dependent. We measure the weight at different amount of protein that we fed. Okay, so right click on the chart, on the empty chart, and this will be appear. Right click this one, this window will be appear. Select the data, and a new windows coming here, and then need to add a series here. Add series. Okay, this series will be add. I want to, you can put the name, you just ignore it, you can put it empty, but because we want to measure PR, I want to put the chart title as PR, or series name as PR. X series is the is your independent variable here. Your X series, click here and choose from the second one. Do not choose the first one. and it's automatically appear here. Then for the y values, make sure that remove this one first. Don't forget this one. This is tricky. Sometimes maybe you confuse. First, remove this equal to 1, and it should be empty. When it is empty, then choose the y. All the y here appear. You can see all the data coming here before we clicking the OK. Okay, that's all. The first step done. We have our data here. The data, this data for x for independent, and these are for dependent variable. We measure this one and we change or we feed the animals by the amount of the protein. So the next one, mostly I hate this vertical and horizontal line. I like this one as clear. So we have the data here. We want to make a line. Just click from on one of the data. Right click on one of the data. Now right click on one of the data. This windows will appear. Add trend line. This one. Add trend line. Okay, I will repeat. Just right click on one of the data, not on the field area. Just on one of the data. Right click on one of the data and then add trend line. When you're adding the trend line, it will be appear one windows here. I need to, okay, yeah, the trend line is appeared here. Depend on the version that you are using, but the latest version is appear here. I want to use the linear, no, the linear, because I want to use the slope A as the PER or protein efficiency ratio. It's linear. Then just going to downside and make sure that you fill these two tick. One is display equation on chart and another one is display R square value. Yeah, these two. Okay, so here we have seen that I should make it bigger. I want to make bigger. You can see, yeah, the y is equal to 2.63. This is the slope of the graph, and the PR is equal to 2.63. If you back to this one, yeah, you know the answer. 2.631. You can see we bring the data and easy we found the PER or a slope of the graph as the protein efficiency ratio. Make sure that R square um, is close to 1. If it is lower than 0.90, sometimes I refer to 95, but mostly 0.90. If it's lower than 90, it means that it's not valid. The regression is not valid. So make sure that in this one, the R square is near to close to 1. Yeah, 97 is very good, and your data is fitted by this linear regression. Yeah. Now, you have one um, equation here to predict for you. Here you have not any data, but you can predict by changing the x, the amount of protein, how much gain uh, it can be gained. So we can use this one as a one fitting model. I want to do this one as another method that we call this one as this method as a least square method. Least square method. In the least square method, we need to guess first the a and b, or every constant we need to guess. For example, I guess a is equal to 1, b also equal to 1. Okay, I guess this one is 1, and this guessing basically coming from the background of the research, and I will show in the next example. Sometimes maybe you cannot easy guess. You need to have some background about the data, how what is the range of the the a or b, or the other constant. So I guess here as 1 and 1, for example. Here, this data is y, but it's not. It's coming from the p, from the practical, from the experiment. So we have x, and each of them have one y. This y is coming from the experiment you measure. I want to have one y as theoretical. It means that based on these two variable, based on these two constant a and b, I want to measure these two. I want to measure again theoretical. Y is equal to ax plus b. Y theoretical. This one is y theoretical. This one is y practical. Y practical we measure, y theoretical we calculate based on our guess. So we calculate here y is equal to ax plus b, means that this amount of a is 1, multiply by x and plus b, this one is b. So I want to calculate here by Excel. If you want to calculate and you want to have your final data, start by an equal. It's equal to this cell, equal to what? Yt ax. This is a. This is a. A multiply by x. This is x plus b. This is b. You can see H2 multiplied by A2 plus H3. This is the amount of theoretical data based on our guess, our first guess. We guess A is 1, B also 1. Okay, so I just want to enter, it's represent 1. And see, it's equal to H2. This is H2. H2 is A, amount of A. Plus multiply by X. X is here. X represent to this Y is here. This is A2. Plus H3. This is H3. So, as the Excel is an intelligent program, so if you copy and paste here, it automatically calculate for this amount of x another yt. But one problem here we have, I just want to show you. If you copy and paste here, Control C, Control V, here it's equal to H3. No, I want to this one as H2. because when you copy and paste in the next cell, everything increase by 1. Here h2 multiply a2 plus h3. When you come here, copy and paste to the next uh, row here, it increase all by 1. But I want to make h2, this one h2 and h3 as constant. If I want to make this one as constant, I need to spend some money. How? h2 and h3 are constant, so I want to spend some money to make a constant. Just put the dollar sign before and after the letter, not the whole. Before and after the letter. h2, I wrote this one as dollar h dollar 2. No, before and after the h. Again here, h3, I want to make it constant. Before h, after h. Okay, this one. And again, I enter. Now here, this is equal to h2 multiplied by a2 plus h3. h2 and h3 are our constant. So when I copy this one and paste all of this data, here, if you see here, when I change to down, just a changing. h2 and h3 are fixed. You can see h2 and h3 are fixed here. So it means that for each of x that I have here, based on my guess a and b is equal to 1, I calculate theoretical data. Now I want to do the I want to add this graph yt also. I have this is yp. I want to add yt to the graph. I add here. You can see, select again data. I right click here and select data again and add another one. This one has t data, theoretical data. The x series again same x series, and y, don't forget to remove the 1, and y is this one. Okay, so our t data are here. Our t data are here. I want to add this one, the legend. I want to bring the legend inside. Okay, you can see our data here. Our guess is here. I can change this one. For example, I want to put the b as 10. You can see it's a little bit changed, but it's not covered our data. So I want to do some changes that this data come and exactly cover our line. How? So first we guess a and b. Yt equal to a multiplied by x plus b. We have some practical data here and we have some theoretical data here. We want to fit this data on this data, or we want to fit this practical data to this model. For this method, a statistician recommended that you can deduct yp and yt together and then make it power 2 and make it sum, and then all of them need to sum here, and this summation must be minimized. So I want to here I want to, for example, yp minus yt power 2. I want to have all of this data. I should deduct yt from yp and then power by 2. I write the expression here. I want to make deduction yp from yt, and then I want to power 2. Okay, make it power 2. So this one I want to apply here. Every data from here. Sorry, one student is waiting. Okay, so here I want to deduct this yp from each of the yp from yt and then power by 2. So as usual is equal, bracket open, yp is here, p2 minus c2, and then close the bracket and power 2. It means that this one deducted by this one and it's going to power 2. Okay, this is the square of deviation. Square of deviation yp by yt. It's a square of deviation. So I repeat this one for all of the data. It means that for each data I deduct yp from yt and make it a square or power 2. Then need to sum all of this data. I want to add each of the deviation, square deviation here. I want to add all of them here. Here we have auto sum on the right hand here, auto sum. I added auto sum. It sum all of this data together. We have this point here. This means that addition of all square deviation. If we minimize this amount by changing the a and b, this two, by changing a and b, for example, if I put the a by 2, you can see it's decreased. Or for example here, if I put this one as 10, it's again decreased. By changing these two, I'm again back to the 1. You can see, by minimizing this cell, by changing this a and b, we find the a and b without the interplay, without the regression. By minimizing the summation of square of deviation, summation of square deviation. This is called as least square method. So we first deduct each of them, then square, make it power 2, and then all of them I sum here. Here, if you going to your it's not easy to changing and seeing is it changed or no. The Excel provide one one useful tool here in the data menu. You can see data menu. Please check your data menu, and you should have solver. If you don't have solver here, just click on file, going to the option, back again, will show you need to have solver here on the data menu. If you don't have solver here, it's okay, you need to add. Just click on file, go to the option, and the option menu, waiting to open option menu, file, option, why it's not open. Have you opened your option? I don't know where is my option. It's not open here. Maybe because it's something secure here. It cannot open. Okay. I just let you know. Going to option and going to downside and find add-ins, add-ins, and then click in front of the add-ins. There is a go. Press the go, and when you press the go, you can find the solver excel add-ins. Yeah, it cannot open here because it's I shared my screen, so it cannot open on because there is some private data over there. Maybe it's inhibited. So if you found that one, okay, have you bring the uh, solver to here to your data menu? I want to check if you bring. Yes. Oh, okay, okay, okay. Okay, Jingming bring. Okay, okay, okay. So I again redo file, press on menu file, option. On the option, there is a window going down, and on over there, you need to check the add-ins. When you find add-ins, uh, press the go, and when the new windows open, just tick the solver and then make it save. The solver will appear here. Okay, I think most of you could do do this one. Okay, so by the solver, I want to show you how you solve this one. I want to minimize D22 by changing H2 and H3. I want to change H2 and H3 and minimize the amount of the summation of squares. So going to solver, open the solver. I want to reset all. Okay. So set the objective. Objective is here. D20, I want to minimize D20 by changing variable. Which variable you want to change? A and B. Just click H2 and H3 like this one. So you can see it's appear here. I want to redo again. The objective is here. I want to minimize this cell, minimize, set the objective to minimize by changing this H2 and H3. That's all. And I want to show you here what will happen by the graph when we press the solve. You can see here our data based on the one and one. I want to press the solve and you will see the magic of the Excel now. 1, 2, 3 going. Okay, you can see all the orange dots coming on our line. It means that it's fitted to our line. And it asks you want to keep the solver. Okay, yes. Okay, can see A is 2.663. Yeah, here A is 2.63 and B is 12.227. Exactly same. No, this means that the uh, curve fitting, or this is using for least square method. A and B, we bring the A and B by this method exactly same as a linear. No need to draw, no need to this one. I just want to show this simple example. Okay, I hope you understand this one. Maybe in the next example, I will redo most of this data that I appeared here. Okay, I will upload the this training video on the YouTube, on my YouTube channel. If you miss something, you can again redo this one. Okay, then back to the our agenda. Okay, the example one already solved and PER there. The next method for curve fitting is linearization. Nonlinear equations may be linearized by series expansion. Another technique for linearization involves mathematical manipulation of the function and transformation. We'll show you how you can manipulate and how you can transform some of the nonlinear to be linear. Yeah, for example, if we want to transfer f x and y to a g x y plus b, we want to transfer our nonlinear to a format of a linear. For example, this one, xy equal to 5. This is a nonlinear, as you know. But if I rearrange and make it as y is equal to 5 multiplied by 1x, 1 over x. This is a linear. If I draw y as the instead of the x as 1 over x, it will be a linear. If a plot of y against 1 over x, this is be linear. Another one, if y is equal to y2 over x plus 4, y2 is equal to, we rearrange, we manipulate, and then finally we reach to this equation by this one, we are rearrange. Make sure when you rearrange, all of the dependent should be one side and independent in another side. Y2 over y minus 4, a new variable we call as z, x equal to z. This is a linear. We rearranging. The hyperbolic function, this one y is equal to 1 over b plus ax, it's non-linear because it's in the dominator, not as power 1. So if we inverse 1 over y is equal to b plus ax, if instead of the y and x, if we draw 1 over y as b as x, it will be a linear one. So this will be linear. Another example is the exponential function y equal to a b power x. Yeah, this is because the x, the independent variable, is in the power. This one also is not a linear. Even the both have power 1, but it's not linear because x is in the power. This is the exponential function. If we log both sides, log y is equal to, as you know the rules of the log y is equal to log a multiplied by log b power x, and x is going behind log like this one. And instead of the y and x, if I draw log y over x, it will be a linear one. If instead of the y and x, I draw log y over x, it will be a new linear model that as you know, the slope will be log b and log a is the intercept. And geometric function y is equal to a x power b. If we have this one again using the log method, log y is equal to log a plus log x power b, and b is going the behind log like this one. And instead of the y and x, if we draw log y over log x, we have one linear. Yeah, this is the semi, if you remember, semi-log paper and full log paper. Yeah, this is log, and this is log and non-log, regular one. Okay. Going to do some curve fitting for this type of example. Data on this is, we have this one, data on degradation of neoxanthine, carotenoid pigment in olive. This, we have the data. The source of the data is here, is as follow: day and concentration. The degradation, or we want to measure the degradation. How? Based on the first, we measure each day the concentration of the xanthine in milligram per kilogram. In day 0, the amount of the xanthine was be 1.4 for 1. Day 4, day, and until the we measure until day 54. The amount of the xanthine is 0.13. The change of concentration with time is first order. This is the first order. If you know about the degradation, this is the first order. See, the concentration is equal to E power, E is the Nepper number, E power kt plus b, kt plus b. This is a first order degradation. By linear and non-linear curve fitting, find k and b. We want to find k and b by linear and non-linear. As for if we want to do the linear, if we take the natural log is based on the e. If we make natural log, and it will be changed as log to ln. lnc is equal to, if we take log, lnc is equal to, this one is coming down because it's coming behind the ln, and lne is equal to 1. Then we have lnc is equal to kt plus b. If I draw, instead of, this is the time and concentration. If instead of the concentration and time, if I draw ln concentration through over time, we have one linear regression, and k and b, we find the k and b. When you find a k and b, you did fitting, or you solve a problem, or you did a modeling. In a modeling, we just find the constant of a of a famous equation like this one, first order, or everything. We just find the constant k and b. For example, for this one, c is equal to e power kt plus b. If I take ln, it's lnc is equal to kt plus b. If I draw lnc over t, I can easily find k and b by the by regression or everything. We can find k and t here. So okay, also we can fit the equation by non-linear. C is equal to this one. I want to fit and show you how you can do linear and non-linear fitting. Okay, the example, open the example 7. Here I want to do the first, I want to do the linear part. In the linear part, we have time and concentration. I want to draw a figure of ln c over t. So I have c, so I need ln c, ln c, ln concentration. Okay, so I need lnc. How? It's easy. This one, because it's lnc. Okay, this one. I want to take ln. It's equal. Excel have all the function. Is equal to ln of ln of what? ln of concentration. Okay, that's all. I take ln, copy and paste here. It's easy. You can see it's decreasing lnc. Yeah. Now, if I draw instead of this function, if I draw lnc over t, I can find a linear function. So I want to make a linear fitting. Okay, just click far from your data, press the insert, press the scatter, and choose the first one. And this one I open, it's empty. I want to bring the data here. Okay, right click, select data, add what? Add series name. You can put name or we can leave it empty. X series is time because time is independent. So X series, our time is here. And the y, don't forget to remove the 1. Instead of the c, I want to draw lnc over t. This one. And then that's all. Okay, we have the data. As you know, I hate this one. I want to remove. Now again, I uh, I want to, here. I'll right click on the one point like the previous one, then add trend line again. This is linear because we have the basic equation. It should be linear because the lnc over t is linear because the degradation is this degradation is first order. So here just come to show the equation and r square. Yeah, it's okay. That's all. Now I want to bold it that you see this one and increase the font. Okay, you can see we have uh, y. What's the y? Is lnc. Y is lnc. X is t. So k, our constant here, the k is minus 0.0429. This is the k, and this one is the b, the amount of b, and r square is r square is r square is 95. Yeah, is okay. Is more than enough for our regression, and regression is valid. If it's over than 95, very good, and it's over than 0.90 is almost okay, almost acceptable. So here we have a line, and we found k and t. Here we found k and t. Here we found k and t, exactly same as reporting here. 0.21, we can put point exact 0.208. Now I want to do the non-linear regression. For non-linear regression, again, um, here we have C practical. It comes from the experiment. We found this one as CP. We call this one as CP. I want to measure CT. CT is the theoretical. Theoretical is equal to exponential or e power k t plus b. So uh, I want to guess if I put one and one, here it's not valid. We should know a degradation. Uh, the constant k is negative. So if we put one and one, I will show you will going wrong result. You For this reason I told you that you need to know a background about your data. So it's better to put almost same or almost in the uh, near to this one. For example, okay, I will put one and one and I will show you what will happen if we just blind fitting curve. If we do blind fitting, uh, in the blind fitting, if we do blind fitting, sometimes we going wrong way. So for this reason, I want to show how you can do your own. Okay, CT is equal to E power KT plus B. So I want to calculate. It's equal to E. E means EXP. EXP exponential 5 exponential of K. What is the K? This is K multiply by T. This is T and then plus B. What is B? This is our guess B. This is K and B. Okay? And then we calculate. If I want to copy and paste here, it cannot be. So again, I spend some money to fix the constant K2 and K3, K2 and K3, K2 and K3 are our constant. Okay, so I want to make sure that this is constant. For constant, we spend some money, put the dollar sign before and after the letter. That's all. And then make it copy and paste to all of the data here. Then again, we do the summation. We sum all the data, and by using the solver, I'm using solver. Okay, is it all? I want to. Okay, here I want to minimize this one. I want to do minimize the D11. This is D11. I want to minimize D11 by changing K and B. This is K and B. Make sure here. This is if you forget to remove this one, all of your data will be incorrect. You know that the K must be negative. So remove this one, and then I'm going to solve the equation here. You can see cannot find a good result. All will be negative. I want to all will zero. But if you uh, want to draw your theoretical and oh, sorry, I made a mistake, sorry. Who didn't? Why you didn't told me? We want to again, again. For the for this one, we need to deduct first CP minus CT power 2. Why you didn't tell me? This one. We need to deduct the practical one minus theoretical one, and then make summation. This one. CP minus CT, and then power 2. This one. Sorry. This one needs to come here. And then we need to uh, sum this one. Why you didn't tell me? Okay, it's okay. So going to the data again, solver, and now reset all. I want to minimize this one, minimize E11 by changing this 2. Okay, and remove this one because the K can be negative, should be negative. So, and then solve. Now you can see we have some data here. K is minus 24 and B is is 0.5. It's far from here. This is because of the first guess. As I told you, if you make if you draw this one, if you draw CT and also C together, you can find that these two data is totally different. So why? Because our first guess are not correct. We put 1 and 1. 1 and 1 is not correct. So it's better because it's negative. K is negative. I prefer to start by minus, for example, minus. We can try and we can check again. And this one I want to start by it's okay by 1. I try by 1. Okay, so again to solver and solve the equation. Now you can see it's almost near this data, and you can check if you want to check that your linear fitting is better or non-linear fitting better. You need to draw because we have not much time. This data also correct because this one is the minimum amount. This one also correct. And if you draw this data, you can see that the non-linear data is most acceptable than linear one. This one there. This is more correct. Because we have not more data, no more time, just I'm going to do the example 9. It's maybe take around this one example 9 maybe take around 10 to 15 minutes. Just be patient. I will because some of you need this solving. Okay, in example 9, moisture absorption isotherm data for a bio-nanocomposite film is presented in the following table. Now, AW and MW. Based on the practical data, fit the gap and polynomial third order isotherm model to data and find, this one is fine, and find the constant. Here in the polynomial, I am looking for A, B, and C, this the capital A, capital B, capital C. And as you know, the moisture absorption isotherm or isotherm data is coming from the relation between moisture content and water activity. I want to find A, B, and C, and also I want to find the gap model M0, C, and K for our data. We have data AW and we have MW. So here I'm looking for M0, C, and K. Okay, in example 9, I am open the example 9. Okay, I have this two model. One model is one model. Sorry, there is something in chat. Okay, I will. Okay, so I want to um, do this modeling MW and AW. I have AW, water activity, and MW, and I am looking for M0, C, and K for gap model, A, B, and C for polynomial model. For the polynomial model, because it's easier, I draw it first, AW and MW. So I want to draw this one first. Just click one cell here far from your data, press the insert, and then scatter, come to open a empty space here, click right, and then select data, add the data. Series name is, I want polynomial. Okay, polynomial. X is AW, and Y is MW. AW is our independent variable, and MW is our dependent variable. Okay, then that's all. Now, because as you know, I hate this line. You can see there is a isotherm, and we need to have the model. As you saw the model here, MW is equal to A, B, and C. We are looking A, B, and C. As you know, it's not plus a constant. This model have not constant. It means that at the AW 0, the MW should be 0. So here, again, right click on one of the data, going to the add trend line. Here in the trend line, instead of the linear, this time I choose polynomial. This is the second order, and I want to add third order. Here, third order, I want to display equation and then R square. R square is 99. It means that is enough for the fitting model. But as you know, here we have one constant here in the model. I make it bigger. We have here, yeah, this one you can see it's a little bit uh, constant. I don't want this constant. So for this reason, I need to put the intercept as 0. It means that when x is 0, y should be 0. So press the tick here, intercept as exact 0. So our model would be like this one. So it's easy. You can find A is 1.5, B is minus 1.5, and C is 0.58. This is a model that we call as polynomial model. Another model is a gap model. I want to do the gap model. Okay, I want to show. Okay, we have this model. MW is equal to this constant and AW. I'm looking to find M0, C, and K based on our data. We have AW and MW, and based on these two, I'm looking for M0, C, and K. Okay, so uh, this is MWP. If you remember, this is come from practical. We measure this one. This is MWT. I calculated based on the gap model. How I calculate? It's easy. It's equal to M0. Okay, sorry, first I need to put a guess for M0, C, and K. As you know, M0 is moisture, is the monolayer water content. Monolayer water content is around zero point 0.1. C is okay. You can put 2 for the starting point, and K for we have the reference that K must be between uh, 0 and 1. So I start by zero point 0.5. The K cannot be in the gap model. The K cannot be going higher than 1 and lower than 0. So it should be between 0 and 1. So I put the first iteration as zero point 0.5. I want to calculate the MWT. How? Like this one. Okay, MWT is equal to M0. M0 is this one. Multiply by C. C is this one. Multiply by K. This one. Multiply by AW. This is AW represent to my data, my Y here. Divided by, I need to put double bracket because I want to open one for this one and one for whole uh, uh, nominator. Okay, 1 minus K, this is K, multiply by AW again, AW, bracket close, multiply by again open bracket 1 minus K, multiply by AW again, AW, plus C, this is C, multiply by K, multiply by AW again, AW, this bracket close, and the whole nominator should be closed, and this is the first one. So the constant should be fixed. So we spend some money to fix all the J. Here J, I put fix all J. Again, this one I want to fix. Again, fix. I fix all the constant. Okay. Then copy and paste all. Yeah. Now I have the MWT. I want to draw MWT that you can see. I want to add the T data. X is same. And Y is this one. Okay. You can see the data now here. I want to put the legend here. The legend. I want to put the legend, and you can see. Yeah, the blue dot is our practical data. The polynomial, as you can see, our polynomial, and the orange dots are our theoretical based on this assumption. Again, we are going to minimize the differentiate, the power differentiate of the practical and theoretical. It means that we need to uh, MWP, it's no different that you deduct which of them from which. MWT, I want to first point 2 is equal to uh, MP minus MT power 2. Okay, I just copy and paste all of this data. And now I want to sum, auto sign. Now I want to minimize this amount by changing this M0, C and K. So okay, so here I want to minimize this cell by changing M0, C and K. Again, going to the data, find the solver. Okay, and in the solver, this one I want to show when it's solved what will happen. Okay, okay, so solver, reset all, reset all. Okay, the objective is here. I want to minimize D12 by changing, minimize D12 by changing this tree. Now I have three option here, and none of them is minus, so it should be marked here. Now going to solve. Now when going to solve, just trace the uh, orange line or orange dot and find what will happen. Okay, you can see all the orange line representing what, representing the gap model. Yeah, the orange dot are our gap model. Yeah, this is our gap model. So the M0 is 0.05, C is 25, and K is 95. And then we investigate. Yeah, this is very good. As you know, very good fitting. M0 monolayer water content is 0.05. C and K is here. C, if it's higher than 2, it will be type 2, and if it's less than 2, it's type 2, type 3. And K must be between 0 and 1. And you can see it's exactly lower than 1. It cannot be higher than 1, and it cannot be lower than 0. Yeah, it's so easy, and you need to uh, try again and redo, and I will upload if you need this field Excel file, I can share it again with you. I think when I save and you again download, maybe it's feeling. So you can have this file, and I'm here to uh, respond to the yeah, Vejia told me that. Yeah, okay, Vejia, thank you. I hope that you understand um, the basic thing. If you learn, it's okay. If you think that need to repeat or need to solve more, I'm free to have another what we call it, another workshop to uh, help you that and make sure that you learn all things. So I'm here. You can open your microphones, and I stop share my page, and you can, if you have any question, you can share and you can ask your question. Okay, stop sharing. Okay, I'm here. If you have any question, just let me know. You can open your microphone and ask, or if you want to share your screen and have any question, I will upload this file to my YouTube channel. You can use this one later.